Good afternoon, everybody. So my name is Trevor. I'm Wafula Trevor. So to go with you through trigonometry, that is advanced level mathematics. Now, trigonometry, of course, from the Greek, we just have two words, trigon. It's a very simple thing. Imagine we are going to just study about how to measure triangles. Trig, you all know that trig or anything tri means three-sided figures. Yes, trigonometry is dealing with studying of a triangle. We are studying a triangle. So in this topic, our foundation is this triangle. This triangle here is what we know as the right-angled triangle. The right-angled triangle has three sides. We have this longest side, which is called the hypotenuse, the longest side. Here, I want to give it an unknown. So let me call it Z. Z. I have these other two shorter sides, and they are making angles with the hypotenuse. I think you can see this one. This down one is making angle theta with the hypotenuse, and then the angle here, this upper angle, alpha, is also being made by this side. So, like I have given all the other sides unknowns, I will call this X, and then I will call this Y. Now, in trigonometry, we have most basic concept. This one, we even actually cover it at the lower level, and we call this concept SOHCAHTOA. Yes? SOHCAHTOA. SOHCAHTOA. So this SOHCAHTOA is having three partitions. SOHCAH, then TOA. I want to consider angle theta. I hope we can all see angle theta. Yes. So considering angle theta, I can have a relationship between the sides of this triangle. The first trig function here, which is in so, S is the sine. So if I want to make a relationship between these sides, I can say the sine of my angle theta, the sine of my angle theta is equal to O is the opposite side. So if my angle, if I'm dealing with this angle theta, the opposite is this line here that is the angle is facing. That is my opposite. So I will call it the unknown, which is Y. So ends with H. So sine is equal to opposite over hypotenuse. Angle of an angle is equal to the opposite of that angle. Cos is for the cosine of the angle, which we just write as cos. So cos of the angle, which angle? We are saying we're dealing with angle theta. The cosine of angle theta is given by its adjacent divided by the hypotenuse. Cosine of angle theta is equal to its adjacent. Adjacent is that line, the line which is in between the hypotenuse and that angle. So since I'm dealing with angle theta, theta is made by, this is the hypotenuse, of course, and then this is the side. So this side here becomes my adjacent. It's the adjacent. So I can say cos of theta is adjacent x over hypotenuse z. What I want us to understand here is which side is the hypotenuse, which side is the adjacent, which side is the opposite. Because many students cram, and when you cram, of course, you are most likely to make a mistake. This y here, when I'm dealing with angle theta, I call it the opposite. Sine of theta is opposite y over hypotenuse, what? Z. What will not change is hypotenuse. It's the longest side. It does not change. But right now, y is my opposite. You are going to see when I'm dealing with angle theta, I mean angle alpha here, this angle alpha that I'm touching, is not going to be the opposite. So the opposite of the angle is that side which the angle faces. That becomes my opposite. The hypotenuse and the side which make the angle, the other side becomes the adjacent. That's why we call this one the adjacent. It's the adjacent only of angle theta because it contributes to its what? Formation. I hope that is clear. Unless I have someone who wants to ask on that. Then I would go on to the last TOA. TOA is that when I have the tan of any given angle, for this case, my angle theta, the tan of that angle is the opposite over the adjacent. The side that's opposite the angle, which is my y. Okay. So that is the most basic part of this topic. We should be knowing that we have another relationship in that right angle triangle that was discovered by a scientist who was like a python on grass. His name was called Pythagoras. So we know the Pythagoras Theorem. Now Pythagoras tells us that if this is my line, my longest side z, and these are my shorter sides y and x, that there is a simple relationship between these sides, basically between the sides. That's what Pythagoras teaches. And he tells us that to get the square of the longest side in a right angle triangle, that is key, it must be right angled, that you simply get the squares of the shorter sides, that is this y side, and you add the square of, you add the square of the shorter sides. Yes, you just add them up. That gives us the Pythagoras theorem. This is the Pythagoras theorem. Now, what we want to do is that we want to have a linkage. We want to do this, to use these two concepts, the SOHCAHTOA and then the Pythagoras theorem, to now get a relationship between angles alone. Because whenever you're dealing with sine of anything, it could be theta, it could be x, we are talking about angles. Cos theta angles. It could be another later, it could be x, it could be lambda, whatsoever. all that we are basically talking about angles. So we have here, SOHCAHTOA is giving us a relationship between the sides and the angle. And then Pythagoras gives us the relationship between sides. So when we use the two, we can get a relationship between angles alone. That's what we want. Relationship between angles. And we shall have delved into the topic of trigonometry. As you can see here in Pythagoras, I have Z, I have Y, I have X. Here I have sine, I have Y and Z, I have cos, I have X and Z, they are mixed. So what I'm going to do is that I am going to make Y, X, and Z, I'm going to make them the subjects in these trigonometric functions. I'm going to make them the subjects so that they can be eliminated. When I begin with my first is that the sine of angle theta is equal to Y out of Z. How do I make Y the subject? How do I make my Y the subject? I will simply leave it on one side and take every other thing on the other side. By I would multiply Z on both sides here. That would be very simple. And I multiply Z on both sides. This Z would die naturally. So I would have Y being equal to sine of angle theta Y is Z the sine of angle what? Theta. Yes, I'm also going to make X the subject. The easiest one to use is this cos. Angle theta on both sides. Times Z. Now this Z cancels out. It's like you're dividing 5 by 5. Yes. So it really has to die. Now, okay. So when I multiply Z on both sides, the Z cancels on this side. It means I'm remaining with X is Z, the cos of theta. We are about to reach where we are going. We are actually deriving one of the identities in trigonometry. We are deriving one of the identities in trigonometry, and then we would start the topic of trig. So we are still in preamble. Okay. So far, what we need now is we need to remember these two things: this one, and then our Pythagoras theorem. So I am going to replace X. I'm going to replace Y. I'm going to replace those two in that identity. We are replacing X and Y in the Pythagoras identity. Pythagoras theorem. So Z squared is equal to Y squared. Now Y squared, I am replacing it with this. Y squared is Z, the sine of theta. Since Y is Z sine theta, here I have Y squared. I would therefore call this Z sine theta squared. Then plus X squared, but my X is Z cos theta. So I'll bring that also. Z cos theta. Cos theta. My good. Z cos theta. Yes, I'll write that better. Z cos of theta, but that is simply only x, but I want x squared. Okay, sorry for that. Yeah, network. Not network. It was sound pollution. So when I solve my identity, I'm going to square. I'm going to make that square to apply on each term. And from indices, from the topic of indices, we know that when I have a b squared, this is the same as applying the square on each term, like a alone squared times b alone squared. This you can prove it by looking at, say, 2 times 3 squared would be the same as 2 squared times 3 squared. It's the same. 2 times 3 gives us a 6. When you square 6, you get 36. And then 2 squared is a 4 times 3 squared, which is a 9. That will also give you what? 36. Yeah. So if I have z sine theta squared, I am at free to call this z squared sine squared theta. Okay. Now, in trigonometry, when we are writing the square on the angles, we don't say sine theta squared. If you say sine theta squared, it would mean it's the angle only which is squared. But since we are squaring the whole sine theta, how we write it is that we write the squared. We write the squared before the angle. That means you are taking the whole thing and you're squaring it. Yes. Okay, you will I think be able to catch up on that. So I don't have cos theta squared. No, I have cos squared theta. I don't have when I square tan, I don't get tan theta squared. No, I get tan squared theta. So when I square sine theta, I don't get sine of theta, then I put a square at the end. No, I first put the squared before the angle. So I have that plus even here the z will be squared, the cos squared theta. Yeah, and these are equal to z squared. Now, those of you who are having actually a mathematical eye are seeing something. Z squared, Z squared. Everywhere Z squared. Hey, so this Z squared can actually go away simply by dividing by Z squared on both what? Sides. When I divide by Z squared on both sides, that Z will disappear. It will go. So Z squared will go with Z squared, and I remain with 1. Some students, when they cancel out like that, they put a 0. Okay? No, it's a 1. Like you remained with 1, even here down 1. And 1 over 1 is simply 1. So 1 is equal to this Z squared sine squared theta divided by Z squared. I remain with sine squared theta plus Z squared, also cos squared theta divided by Z squared. The Z squared and Z squared will cancel out, and I'll have cos squared theta. So, ladies and gentlemen, please welcome to trigonometry. This is the basic identity of trigonometry. Okay. So that is our basic trig identity. It is going to give us the relationship between angles of different trigonometric functions. When I say trig functions, I am meaning sine, cos, tan, and others. In fact, before we go any further, let me also remind us on the relationship between the other trig functions. One of the trig functions we've not talked about is called sec. It's called sec. Sec in full is secant. Sec of an angle theta, sec of an angle theta is 1 out of the cosine of the same angle. And then if I have the other one, the other trig function, which is cosecant. Cosecant. Now for us, we cannot say cosecant all the time. We shall just say cosec. Like sine, well, anyway, sine is sine. It's just one e that we've removed. Cosine, we just call it cos. Tangent, we just call it tan, but it's tangent. So cosec of an angle theta is 1 out of the sine of that angle. My God, I have written very well. I have written very well, like some students. Okay. Yeah, so there is also this basic relationship that sec of an angle is actually can be written as 1 out of the cosine, and cosec can be written as 1 out of the sine of the angle. Simple way to remember, because someone will say, oh, how about if I maybe someone could interchange and say sec is 1 over sine, cosec 1 over cos. How you will not do that? I want to see the AC and the C. The C and the S. Each one takes 1 C and 1 S. If I'm dealing with sec of theta, it's 1 out of cos. I cannot have 2 S together. Sec theta is 1 out of the cosine, and then cosec theta is 1 out of the sine. Okay. Kali, that is okay. We are done with that. So in all that we have done, what I could say they are key, very key, that you should have is you should have this SOHCAHTOA. Should know SOHCAHTOA. We are going to use it, I don't know how many times, all the time. You should have the Pythagoras Theorem, and you should also have this identity. This identity, the first trig identity that we have derived. And even now in this lesson, we are going to derive from it more, at least 6 identities. So if someone knows this one, you will not have to like cram the others. You will just derive them. Like you become the mathematics. Not like you remember. No, you don't. You need to remember those few things that I'm emphasizing. The other ones, you just become the source. Okay. So I'm going to rewrite that starting from the right hand side. My identity was 1 is equal to cos squared plus sine squared theta. So I'm going to instead write it starting from the other side, and I'll say that the sine squared of angle theta plus the cosine squared of angle theta is equal to 1. So I'm going to simply play with that. The first thing we are going to do is to get a relationship between sine squared theta, and cos squared theta. So the sine of the sine squared theta, I can decide to take this cos squared theta on the other side, this one. I can just make it cross the equal signs. And well, whenever it crosses the equal signs, we have to change its sign, have to change its symbol. Since we had sine squared plus cos squared, we are now, when it crosses, going to become minus. Minus. So the sine squared theta is equal to 1 minus the cosine squared theta. Okay. That is the relationship between sine squared and cos squared. It is going to help us in that in some equations, as we're going to be solving, we shall need to convert from sine squared to cos squared, or from cos squared to sine squared. Now, as we have done and taken out the cos squared on the other side, I also want to write another identity. This was identity number 1. This is identity number 2. Due. The French said due. So when I now leave the cosine, still on this first angle, when I leave the cosine here and I instead carry the sine and I take it this side, I will have cos squared theta will be 1 minus, now if I leave cosine on one side, it means it's the sine which has gone this side. Yes, so it's going to be 1. The sine now becomes minus 1 minus sine squared theta. 1, 2, 3. However, maybe my question does not have the squareds. My question could have the angle, I mean the sine, but it's not squared. So I can juggle these two. We are going to play with those two to see if I am converting an angle that has no squared. How do I do? And it's basic. I think we just take a root on both sides. You take a root on both sides. If I'm starting with this first one, I will take a root of sine squared theta will be the same as me taking the root of 1 minus cos 1 minus cos squared theta. What I've done, I've taken the root on both what sides. Yes. So when you take a root on 1 minus cos squared, I mean on sine squared, you get sine. Did you know that? You get sine theta. Sine theta is the root of 1 minus cos squared theta. Yes. Okay. So this is number 4. Okay. Like I have done for sine by taking square root on both sides. Why am I mean? Let me also do for cos. Like, how do mathematicians be mean? Okay. Cos squared theta. I take a root on this side. I also take a root on what? On the other side. So it is the same as the root of 1 minus sine squared theta. Okay. And when you take a root of a square, you just get this cos2 will cancel out with this what? With this root sign, and we shall simply get cos theta. Cos theta. Now, there are some students They are not in this class, I'm sure. But there are some students who will do this. Eh? And then they say, oh, square root of 1 is 1. And square root of sine squared theta is sine of theta. The good thing, those students are not present. That is wrong. It does not apply. It's not true. It's not true. So we leave it in the square root signs. We just substitute. If we have the figures, we'll substitute the figures and we get the final answer, which would be maybe a 4, and then we take a square root. That's how we do that. So this, you say, but why is it that this side you are moving the square root, this side you're not removing? No, because it is mathematics. And mathematics says if you have the root of a squared, this cut 2 and the root can cancel, because the root means power a half. So it's like a half times 2. They just cancel and remain with 1. So you get a. That is why this one can get out of the square root. But this one, no, it cannot. This side can't. This side cannot. It's not one term. For us to take the square root, we should have one term, and we take its square root. Or if we have a perfect square expansion, which we don't have. So here we shall leave this as the root of 1 minus sine squared what? Theta. This is pentagon 5. That's pentagon 5, equation number 5. Oh, we said we are going to get like how many? Very many. So allow us go back to the first equation, which is the mother of all these ones. So I'm going to rewrite it down, and then we continue deriving other identities from it. It is the sine what? The sine squared of angle theta plus the what? The cosine squared of the angle theta. You get 1. You get 1. So what I'm going to do is that I know that, or I should know. Let me not assume, because I've not talked about this in this lesson. The tan of theta is the sine of that angle over the cos of the very what? Cosine of the very angle. Yes. So I want to generate an identity in form of tan from this one. I can get in form of tan from this one, because I know sine out of cos gives me tan. So since I have here sine squared, what I'm going to do, I'm going to divide by cos squared. I'm going to divide by cos squared. Now in mathematics, you are allowed to make any change, but as you make the change, make sure you don't change the meaning. So when you decide to divide one side by cos squared, do the same on the other side, so that the meaning remains the same. So we are dividing by cos squared on both sides. There you've not altered the meaning. Okay, so these numerators are all going to be divided by this denominator. Yeah, okay, I will not hope that will be obvious. I will take us through maybe the most primal. I can split this numerator, and I'll have the sine squared theta. My good, theta is like, okay, the sine squared theta over our denominator, which is cos squared theta, okay. Then Also, this cos squared will also go with the denominator, plus cos. Oh, my good, my God. Okay, the cos squared theta will also be divided by the same denominator. The denominator will divide all the numerators. Yes, we should be familiar with that. Even if you have 10 numerators, like a plus b plus c over d, I can separate them, and a goes with d plus b with d plus c with d. So that is simply what I have done in this identity. Each one of them, I've let it to test the denominator. Test, like testing, like you have co also. Okay, so these are equal to a bit earlier on we said 1. Let me remind us. We said 1 out of cos was 1 out of cos of an angle theta is sec. Yeah, I hope you click. We said C and S, like each one takes 1. So if I have here 1 out of cos in my identity, I hope you can see 1 out of cos is sec. So if I have 1 out of cos squared d, cos squared is going to be sec squared d. It's going to be sec squared. It's going to be, it is going to be sec squared theta. Yes, now let me rub something so that I don't make the work so dirty. Don't make the work so dirty, because we are clean people. Advanced level learners. What's the meaning of the word advanced? Like we've gone ahead, we are above the ordinary. The other one is ordinary level. This is advanced level. Okay. At least there we are not very dirty. So I'm going to apply the divisions. Sine squared over cos squared. Since sine of theta, okay. Since sine of theta over cos of theta gives us tan of theta, I actually have it here. I'm not going to write it again. Sine of theta over cos of theta gives us tan of theta. So if each one of them is squared, also the tan will be squared. So tan squared theta, tan squared theta then when you divide cos squared by cos squared, it is like having 5 over 5. So automatically, like why are you explaining even? Like automatically, it is 1. Yes. Tan squared, cos squared theta over cos squared theta is 1. Yes. Okay. So this is identity number 6. Hey, you may say, but why are we deriving identities? Hey, we are going to, we are supposed to be able, like, if I give you an equation and it has sine, cos, tan, I may want you to convert all of them to one form only, to only one form, and then you solve it easily, like a quadratic equation. So we need to have a relationship between almost everything. We need to know a relationship. How does sine connect to cos? How does cos connect to tan? How does tan connect to sec? Yes, and this one gives us the connection between tan and sec. Yes, tan and sec. So we were on identity number 6. Since I've divided by cos squared all throughout, I'm also going to divide by sine squared all throughout. Oh, okay. So what we do, let's first finish all the identities from here, then the other division can come in. Here they will be flowing. So since I divided by cos squared all throughout, this time I'm going to divide by sine squared all throughout. So my identity is the sine squared of the angle theta plus the cos squared. Hey, it's like I'm writing about which language? Why Indonesia? Okay, let me write in mathematics. Plus the cos squared of angle theta is 1. This one we have overwritten it like even if you didn't want it, has stuck in the head. Like even when you close your eyes, you can see it. So I'm also going to divide on both sides, or I'm going to divide all throughout by the sine squared theta, just like I did for the cos squared theta. And we said in mathematics, you are not changing the meaning if you do it well. And that means whatever you do on one side, also do it on the other side. That is not changing theta. The sine squared theta. Okay. I would love to begin from this side. We said 1 over sine theta would give us, remember we have the other two trig functions, sec and cosec. So 1 over sine would give us what? Oh. Yes, please.
It gives us cosec squared theta.
Okay, yes, cosec squared. Very, very true. 1 over sine gives us cosec. Since we have a squared, it gives us the cosec. Cosec squared theta. I have written cojec. Let me remove the j. Cojec. It's like we're not speaking like we don't have teeth. It's cosec. Those who don't have teeth are those who say cojec. Sine squared over sine squared, we get a 1 plus cos squared over sine squared. Cos squared over sine squared gives us a cot. Hey, had we spoken about it earlier? I don't remember whether we have spoken about it. But anyway, it has come. Let's speak about it. Let's speak about it. Sine theta over cos theta is tan. We are very agreeable on that. Sine theta over cos theta is tan. It's here. Tan theta is the sine theta over cos theta. So if I interchange this side and I get cos theta, my God, language. Which language is this? Right, in mathematics. If I interchange and I start with the cos of theta, divide by the sine of theta, I get cot. I get the cot of theta. Cot theta over sine theta, I get cot. Sine theta over cot theta is the famous tan. And actually, the two can have a relationship with each other. The two have a relationship with each other, a beautiful relationship. That cot theta is the same as 1 out of tan theta. Cot theta is 1 out of tan theta. Yes. Okay. So let's go back to where we were. Let's not get lost in the detail. So we have formed another identity. Yeah? The others have been identities, but this one is a identity. Identity number 7. 7 for perfect. It's the perfect identity. It's not called that. Okay. So these identities that we have written are giving us the relationship. We could get as many. I think the time would fail us. However, what we are simply doing is to make sure that we understand how they relate, and that would make our work so beautiful, so easy in the what? In the other parts of the topic. So the other background concept that I would want us to share is that since we are studying about angles, if I have here my circle, how many degrees are in that circle? How many degrees make up the whole circle? Okay. How many degrees?
Yes, 60.
Yes, 360 degrees. Yeah, this one at least you should have heard in songs. They talk about like I am everywhere, 360 degrees. Those celebrities. Yes. So it is 360 degrees. That is my the whole summation of what of the angles. So I am dividing this circle into quadrats. Quadrats, quadrat simply means 4 equal parts. 4 equal parts. Quad is for 4. So 360, I've divided into 4 equal parts. It means even the angles have been divided into 4 equal parts. And when you prove on your calculator 300, when you divide by 4 and you don't get a 90, you leave that calculator. Leave that calculator alone. Every angle here is 90 degrees. It's 90 degrees. So I call this the first quadrat. I call this the second quadrat. I call this the third quadrat. I call this the fourth quadrat. There are 4 quadrants: the first, the second, the third, the fourth. So I always begin measuring my angles from here. That is my 0 degrees. When I move from here to here, this becomes 90, and I continue. That is 360. Hey, Jesus. 90, when I add 90, I'll get 180. When I continue, I should get 270. Yes, 270. And then finally, when I add the last 90, I get 360 degrees. So each quadrant there is 90 degrees. Each quadrant is 90 degrees. Now, I would not go into the, just because of time, I'm not going into the derivation. But at least I will give you a formula to use to remember. If we would want derivation, we shall do it another time. In the first quadrant, all the trig functions, any angle that falls in the first quadrant, from 0 to 90, any angle between 0 and 90, could be 60, 30, 12, 1, 89.9. When you take their sign, say I take sine of 60, I get a positive solution. Sine of theta, cos of theta, any angle, and tan of theta, all of them are positive. All of them are positive. Maybe let me just tell you the basic reason. This is like the positive x-axis. This is also the positive axis. So since all axes are positive, sine, cos, and tan will be positive. Now, when I come to this second quadrant, the second quadrant, only sine is a positive. If you take sine of any angle between 90 between 90 and 180, so you take an angle of 91, take an angle of 179, all of them, if you take their sign, they should give you a positive figure. Okay, these things are going to make sense. In case for you they have not made sense, you're going to basically when you are doing when you are finding angles, because we are going to find a lot of angles using the equations. If I say sine is positive, I am also saying that the others that have not said they are positive, they are automatically negative. So if you pick your calculator, in case you have, and you press cos of 100, cos 100 falls between 90 and 180, cos of 100, cos of 120, you must get a negative. Also, when you press the tan, you must get a negative. I have here my calculator, and just that I cannot project it. I hope you also have yours. Let's all press sine of 120. I am getting 0.58, which is a positive. But if I try to press cos of 120, the cosine of 120, I should be getting a negative. I should be getting a negative. You may not get a negative, by the way, if you have not set your calculator well. Your calculator should be in degrees. Calculator should be in degrees. Some calculators could be in radians. So you need to set that to the degrees, and you'll have that well. Also, you can press tan of that very angle, tan of 120, you get negative root 3 or negative 1.732. So that proves us that in this second quadrant, only sine is positive. Angles between 91 and 179 could even be 0.999999999. Now, in the third quadrant, it was proven that only the tan is positive, tangent of an angle. Only the tan is positive. Like here, only sine has been positive. If you take, I think between 180 and 270, 200 lies there. If you take tan of 200, you should get a positive figure. I'm getting positive 0.36397. But if I take sine of the same angle, I get a negative 0.342. I hope someone is with me on the calculator. If you didn't come with a calculator, go and borrow. Go to the next class and borrow. Okay, I know this class, all of you have come with calculators. Okay, then for the last one, cosine is positive. Cosine is positive. Yes. Now, there is a simple mnemonic for us to remember. The first quadrant, all, I'm going to take the A. The second quadrant, sine, I'm going to take the S. The third quadrant, tan, I'm going to take the T. The last quadrant, cos. ASTC. ASTC. Different students have their, usually make other words. they make their own mnemonics, but that could be all students take coffee. All students take coffee, taking in mind that we start from the first quadrant and we take we move anti-clockwise. All students take coffee. Others say all students take chemistry. All student teachers cane, etc. Those are the good ones. Others are not good. I'm not going to mention them, but those are good. You can take them. Yeah. So that is that with that quadrant. So even if you cannot know the exact figure the calculator gives you, but if I ask you that sine of 90, I'm not 90, those boundaries, we leave them. Those boundary values 0, 90, 180, and 270. The boundary values, we're not considering them because sometimes they are zeros. 0 is not positive and 0 is not negative. Anyway, that is obvious. Why am I talking about it? Okay. If someone says sine of 60, you should know that it's going to be a positive. Cos of 60 is going to be a positive, even if you don't know the figure. Tan of 60 is going to be a positive because all of them are positive that are below 90 degrees, between 1 and 90 degrees. If someone said that sine of 100, you say, oh, wait, 100 is beyond 90. So it is in the second quadrant. Okay, sine of 100 is a positive. By knowing that in the second quadrant, sine is positive. In the third quadrant, tan is positive. In the last quadrant, cos is positive. Maybe what I can do in this remaining time is simply to give you something to try to see whether you to bring back by what you have learned. Yes, that's how the brain works. When you study and you finish, you may think you have grasped everything, but when you try out, you actually grasp. You don't now think, you grasp. Yes. Okay, so I'm going to use this space here. The next concept that we are now to enter is solving equations. See now how mathematics is starting. Solving equations. That is the next concept. But let me give you something. Express. The following in form of sine squared theta. Express the following in form of sine squared theta and the first one is the first one is sec. Okay. The first one is sec squared theta. The other one is cosec squared theta. When I say express in terms of sine squared theta, I am saying you should not have any other trig identity in your solution except sine squared theta. You should not have any other trig identity. except sine squared theta. Okay. Yes. That is our simple assignments. In fact, you can do it here and you tell me some of tell me what you are getting. Sec squared theta. When you express sec squared theta in terms of sine squared theta, what do you get? Do I have anyone who has done that? Has.
Yes, we have tried.
Yes, please tell me.
Let us try.
What do you have? Okay.
Excuse me.
Yes, please.
I think the first one should be 1 minus tan squared theta, but then tan squared theta is sine over cos.
Which is still okay. Okay, so at least you have done some step. So sec squared you said is 1 minus tan what? Squared. And tan squared is sine squared over what? Cos squared. Now, can you change that? Can you leave that sine squared and you change that cos squared into sine squared? Is it possible?
Yes, it is possible.
It will be 1 minus tan squared theta, but then tan squared theta is equal to sine squared theta divided by cos squared theta. But then cos squared theta is equal to 1 minus sine squared theta.
Yes, so you have finished removing everything. That is where we ended. You've expressed fully. That is very right. Very right. Yes, I think you have learned something.
Thank you so much, Teacher Trevor, for today's lesson. This class and all other classes are always recorded and they are uploaded on the Magezi platform. You can always access them for reference and for further enlightenment. Thank you so much, everybody, for joining in. This is adjourned.